So the lesson that I taught earlier today was on perimeter. I'm going to do that with you tomorrow. Actually, I want to do area first, okay? So the area of a shape. If I did the area of a square, so let's say I'm asking you, find the area of this square that has a dimension of 7 centimeters. And I asked you, what is the area of this square? Well, in grade 7, or even in grade 6, or even grade 5, you guys would know that it's side times side, or side squared. Some of you say length times width, but it's really not, because length times width would be more for your rectangle, because they're different dimensions, whereas a square has the same sides, right? So you would do here 7 to the power of 2 is equal to 49, and the dimension, since it's centimeters, it would be centimeter squared. Pretty easy, pretty easy, pretty easy. I'm going to replace the number 7 with a monomial. Ready? Ready? Here we go. So what if I told you that this side would be 7x? Let me make the x not look like a times. 7x. So again, it's still area equals side times side, side squared. So you would get 7x times 7x. That would equal 2. That would equal to? Exactly, 49x squared. So we're actually going to make this an enrichment because of enrichment. Okay? 49x squared. Good. Pretty easy. Let's take a rectangle and make the width 3x and the length 2x plus 5. So the area of a rectangle, I heard it earlier, was length times width. Width times length, length times width, it doesn't matter. I removed the times so that we don't get it mixed up with x. So would we be able to find the area of this rectangle? Now remember, I'm not getting an answer with a value number. I'm just getting an answer in algebraic expressions, which can sometimes be reduced. Yes?
So you do 3x and then 2x plus 5 in brackets?
Exactly.
So that gives you 6x squared plus 15x.
6x squared plus 15x. Perfect. Is this my final answer here? Is this my final answer here?
For now, yes.
For now. There's nothing else that you could possibly do except give me the simplified version of what the length times the width is. Now, had I told you the value of x, then I can get a numerical answer. So had I said to you, hey, by the way, x is equal to 3. Then you'd be like, okay, let me get my answer here and replace the x by 3 to get a numerical answer, which would be 3 times 3. So now I'm evaluating. 9 times 6 is 54. 15 times 3 is 45. And then it equals to 99 centimeter squared, meter squared, unit squared, depending what I had made these dimensions. I won't always give you x as a value. I might ask you just for the simplified version, and this would be enough. Is that okay? Since we're in the enrichment class, I could actually give you a square check this out. So here's my square. All sides are equal on a square. And I'm going to give you a binomial. This is going to be cool. 2x plus 4. And I'm going to ask you to find the area of this, which is actually going to be using your foiling. The first question we did on the bell work, a binomial times a binomial. Can you find the area to this square? Take a minute and see if you could set it up and do it. So if I asked you find the area of this square, you should be like, oh, this must be side times side. I don't have this side, but obviously it's the same as this one. So it's really area equals 2x plus 4 times 2x plus 4. And this we know how to do because we know how to multiply binomials by binomials. And I would use my arrows on the top. I would do 2 times 2 is 4x squared. I would do 2 times 4 is 8x. 4 times 2 is 8x again. And 4 times 4 is plus 16. I would be left with my 4x squared. Here, I would put these together as plus 16x's, plus 16 as my constant. Is this the final answer? Yes, this is the final answer. Yes, this is the there's nothing else I can do. What else could I possibly do? Yes?
If you know what x is.
But I didn't give you the value of x. So if I don't give you all you can do is bring it down to its simplest form, which means to either distribute, simplify, gather like terms. This is it. That's it. Finish. Don't do more. The more you do, the more marks you're going to lose because it means you don't understand. All right? Let's try another shape. Let's try a rectangle. Let's try a rectangle. So check this rectangle out. Here's my rectangle. 6x plus 10 and 3x minus 1. Try finding the algebraic simplified version to the area of this rectangle, please. I'm going to set it up for you. So 6x plus 10. So it's length times width, correct? Area equals length times width, length times width. This is my length. Timesing it by my width. This is what I learned in grade 7. Length times width. My length has a 6x plus 10 expression times my width of 3x minus 1. So I'm going to use the foiling to foil 6x times 3x, 18x squared. 6 times negative 1, negative 6x. So far, so good. 10 times 3, 30x. And 10 times negative 1 is negative 10. The last thing I should be able to do here is combine these two because they're the same. They each have x's. So this is a plus 24x. I have a negative 10 here, and I have an 18x squared. Good? Is this my final answer?
Yes.
Yes, this is my final answer. Unless I give you the value of x. If I give you a value of x, if I tell you x equals 3, then you need to take this and replace these x's by 3. And then you would have a final numerical answer at the bottom. Good?
Yeah.
Let's try a triangle. So the first thing that I would like to see, is the formula. Area of every triangle in the whole world is base times height divided by 2. Do you agree? You take the base, now it doesn't really matter if you interchange them, so you take the base of 10x, times it by the height of 6x plus 2, and you divide by 2. So the first thing I would do if I were you would be to distribute my 10 at the top. 10 times 6 is 60x squared. You got that?
Yes.
10x times 2 is plus 20x's. And then I would divide all this by 2. So what happens is I have, final answer, 30x squares and 10x's. Is this my final answer?
Yes.
Yes. Unless I give you the value for x, you cannot go further than this. Yes, sir.
I did the 6x plus 2 before, I switched
Perfect.
them around and I got the same answer.
It won't change, right? Because base times height and height times base gives you the same answer. So 2 times 3 is 6, just like 3 times 2 is 6. So when you're multiplying, that's why x and y is the same as y and x. Because whatever the value to those numbers are, it's going to give me the same answer. Got it? Good. So this is probably the most difficult question because of the formula. So who remembers the formula? Good, I'm happy some of you remember the formula to a trapezoid. Go ahead.
It's base plus length.
So it's a small base plus a big base, and these are your bases. They're parallel to each other. That's a base and that's a base. So you add up the two bases. So small base, you can call them whatever. You can call them yin and yang. I don't care. But you have to know what it means. The bases are the parallel lines. One's usually smaller than the other. So base plus base times height.
Divided by 2.
All divided by 2. So already, if you remember this formula, you're already ahead of the game. If you don't, you need to remember that it's very easy. It's just adding the two of these, timesing it by the height, which is usually the line that's perpendicular to those parallel lines, and then divide it by 2. Don't forget to divide by 2. So, we actually have to add 4x plus 10x plus 12. So I'm going to do that here. So 4x plus 10x plus 12. And then I have to multiply it by the height. Now, does it matter if I put the height here or if I bring it to the front?
No.
Same thing. I'm going to leave it in the back just so that you get used to seeing it in the back. Divided by 2. So this gets distributed, this gets distributed, and this gets distributed. So I would do 6 times 4 is 24 x's. 6 times 10 is 60 x. And 6 times 12 is 72? Maybe? Yes. And can I do anything else besides this? Before I divide by 2? Before I divide by 2, I could actually put this guy and this guy together. So here I would have 84 x's plus 72, all divided by 2, leaving me with 42 x's. Where did I get that? 84 divided by 2 is 42 x's. And 72 divided by 2 is?
36.
Count this, 36. Is this my final answer?
Yes.
Yes. Can I do anything else with it? No. If I don't put units, you can write units squared. Or you can write centimeters squared. That's if I don't give you any and you have to assume. Yes?
I simplified the 40 to the
Perfect. Did I give you the same answer? Good. Next. If you don't put the brackets here, I don't know how you knew that you had to add them first. Because if you don't put brackets, what happens is you have to do the multiplication first in order of operations, which should give you the wrong answer. So the brackets tells me that I need to add this plus this, then multiply by the height. If not, what's going to happen is one of the bases is going to be multiplied by the height. And that's not going to give you the right answer. It's important, the brackets. Do we do one more? We'll do one more like this so that you have it. Yes?
For the unit squared, do we do that when it's like on the expression or just the final answer?
Final answer. Final answer. I don't want you to carry around units all over the place. It's really, so I'm doing one more trapezoid. One more trapezoid. Let's see if you can get it. So here are my two parallel lines. I'm going to give you my height over here. So my height is 4x. This one here is 10x plus 6. And this one here will be 2x. Again, I don't know if you're going to get a decimal, but I'd like you to try this question out. So my height, 4x. My big base is 10x plus 6. And my little base is 2x. So start off by writing the formula, the generic formula that you all know from grade 7. Then start replacing them by the little monomials and binomials that I gave you, and then solve it. So we're going to answer this. I gave you some time to do it. I asked you to first put the formula. So it's base plus small base times height divided by 2. My big base, 10x plus 6 plus 2x. Now some of you might actually do this here. You're like, hey, I know that this is 12x plus 6. And simplify right away.
Does it make a difference if it's small base or plus?
No,
base?
these two, when you add, 5 plus 2, 2 plus 5, they both give you 7. So it doesn't matter the plus, like which ones you start with, okay? So that's fine. So then you multiply by the height, which happens to be 4x. And then we're going to divide everything by 2. So 10x plus 2x is 12x plus 6 times my 4x divided by 2. Now I'm going to bring the 4x to the front just to show you that they both mean the same thing. So 4x is first multiplied by the 12x plus 6, all divided by 2. So now my distribution, and this is enriched because I don't teach x times x to my regular students. So you need to know that this is 48x squared, and 4 times 6 is 24x's, all divided by 2. Final answer, 48 divided by 2 is 24x squared, and 12x. Final answer, units squared. Who got this? Good. Those of you who did not, if you have questions, you let me know now. If I clarified, if I cleared up anything that you didn't know, that's great. Yes?
I multiplied the 4 with the 10 and the 6.
Sure, this should give you the same answer. This should give you the same answer.